The Sporlan division of Parker Hannifin proudly sponsors the Advanced Refrigeration Podcast. There are a lot of questions surrounding the transition to A2L refrigerants and a lot of talking heads disseminating nebulous answers. But when your technician is face-to-face with the first A2L transition project, where do you turn for real-world answers about this specific job? Parker Sporlan's Virtual Engineer is an innovative online design tool to size and select the correct components for climate control and refrigeration applications. Get your A2L system flow and component selection answers in 3 simple steps. Enter your application details, size, and select products, then download your project files. It's that easy. Try it at absolutely no cost. Visit sporlan.com and navigate to the Resource Center. Parker Sporlan, leading the charge.
Yeah, so you're wrong, just letting you know that from right now. Because I know every time I get delayed or canceled or whatever for any kind of airline, because I usually fly
It's a one-off. It's a one-off. You took one.
No,
airline.
2 flights. Both flights that I took for Delta ended up, one got totally canceled, the other one got delayed, and the other one got delayed.
Listen, I have flown American 3 times this year, and every time it's been delayed. I fly Southwest every time. Out of the last 3 years, I've had 1 flight delayed at Southwest, and that was when we were leaving HR. And I moved my flight, and I got the last seat, and it was a blizzard back home, and it was delayed by 35 minutes. I've never gotten delayed like you do. It's insane.
Are you and the other kids talking about it?
Yeah, it's ridiculous.
You joke about it, and I'm like, yeah, no, I'm sitting on the tarmac.
I know, because my wife said, I haven't seen his delayed post yet. She's like, it's coming. Isn't he flying soon? I'm like, yeah, he's probably getting delayed right now. At this point, you should have so many like free bonus points from them for getting delayed. Because isn't it like after 2 hours?
I don't know. I gotta start looking at the bylaws.
I'm almost positive after 2 hours, you're supposed to get like compensated.
I think I got $12 from Delta when I got.
At this point, like you've been railroaded so many times, like you should be getting like $1,000 every time. This is ridiculous.
I have to look at the bylaws.
Yeah, there's laws for this.
Something in there. Good afternoon, everybody. Welcome to Advanced Refrigeration Podcast. You're the host, Brett Wetzel and Kevin Compass. And yeah, it's really me. I'm on the verge of sounding like the lady from the casino because I've been talking so much this week. My coworkers don't even want to ride or fly anywhere near me anymore. Like they thought it was a joke because I would joke about it. I was like, no, I get delayed a lot. And
I don't talk to you before I fly out because it's bad juju, and then everybody else is convinced. The rest of us are convinced too.
I told them that too. They're like, they don't. I was like, the rest of the guys I talked to, I said they don't talk to me on days that they were flying or upcoming to the days that they were flying. I won't be able to get a hold of them.
Yeah, we block you on Messenger until we're getting ready to take off because it's bad luck.
Yeah, it is. So this week I was at NASRC out in Minnesota and taught 2 classes Tuesday and 2 classes Wednesday. I don't know. Bunch of new stuff coming out. I saw some lovely looking CO2 little rack thing made by a manufacturer I don't know. I'm scared.
Oh boy.
I'm scared. What are you doing? What did you do this week? I barely talked to you because I was flying and sitting at the airport for whatever.
I did some random week. Beginning of the week, did some CMRC retrofits on some like pump skid compressors that we added to a rack, and actually it went fairly well. I was fairly impressed about how well it was put together already. for you. Everything was pretty much assembled. The only real pain in the ass of it was like rewiring the compressor and making everything longer because like it stacks in that there's a box. The CMRC goes on top of the electrical box, and then it's like everything's going to fit through a hole. So a lot of the wiring had to get extended inside the pecker head of the compressor, which kind of was a pain, but they getting it all through and set up. And some of the wiring was a little bit different, and getting some of the instructions obviously translated. That part was a little difficult, but once we found a different diagram, there was like a little sheet in there that like made it like cake afterwards. It literally took this rack from cycling a couple hundred times a day on compressors to like less than 50 when I checked it this morning. And I still had a bunch of tuning to do on it. Like I just barely got a base tune in there on MT, and it just took off.
So how many of the compressors are have the module in there?
So it's just one. I just did one because we only had one Bitzer on this rack. So we just did one, or it was one on each rack. And I only had from the factory, from Zero Zone, when they made the skid, they only had 2 unloaders on there. So instead of getting a third head, we probably could have put one more unloader on the middle head and brought it down to 10%. It would have been even better. But
so this was a glycol skid.
No. Old DX rack that we did a big remodel on, and they added some horsepower to it to make up for some shortfalls of it having horsepower. And I was thoroughly impressed. I think if we would have put the third head on there, it would have been like a million times better. But we would just work with what we had because it was a 3-cylinder or a 3-headed compressor, 6-cylinder. So we were unloading 2 of the heads. Yeah. It's way more aggressive than the old, was it Ferris Stepper?
Siemens controller guy.
Yeah, like it way more aggressive. And
do they all unload all at one shot, or is it like staggering it?
It does both.
I know it does both heads, but I'm saying, does it like? Go ahead, explain.
So it'll hit one head first, and then it'll unload the next head, and then it'll pulse one, and then pulse the other. So it was way more aggressive than the older Siemens module unloading. Way more aggressive. And the nice thing is you got the app.
How low will it unload?
It'll go down to, they say 10%, but it'll unload out. If on a 6-cylinder compressor, you could load on all 3 heads.
So okay, so 10% of the whole. Oh crap!
Yeah,
okay.
So that's what's nice about Bitzer with bigger compressors, because like on a Copeland 4D, you just get one head with the digital unloading, so you get a lot more capacity control out of doing all 3. It's a lot nicer for that part of it.
You get a lot more capacity control over it, like you said. Like you have a 4D, you can only basically unload it down to 50%.
Yep.
And then so like it would be. I wonder why Copeland never did that. Obviously,
so there's on the other head, the left-hand head, there's something to do with the oil porting. So that's why you always see the unloader on the right-hand head.
Is that where it has that like oil equalization thinger? Like,
yes.
It's like that tube that goes up, and sometimes when you press it and you have blowback from the other one while you have the heads off, it'll blow up at you like Mount St. Helens.
Yes.
Why are you laughing at me?
Because I've done it and it's not good.
It's not good at all.
It's not good at all. Like that I always leave that head on if I'm trying to bump it. But yeah, I will say this: when I did wire it up, the only thing it is not the best if you're using the Bitzer tool, like the Connect tool on your laptop, and not the Bluetooth. The 24-volt enable signal comes off that plug. So that plug, if you have it, you can't have it enabled and watch it run. So what I found is there's another 24-volt output on that board on one of the plugs for the transistor or something. I end up moving it there. That way you could have the data cable still hooked up to it and still pull the data off of it.
Can you send me the documentation?
Yeah, I will. I'll have to send you pictures of it. It's paper manuals.
Oh, you don't have the actual... Really?
So the only thing that was confusing was when it got down to the oil control, and they showed a DP1 in there, which they show it normally open. Okay. I ended up with a DP2 Cree1 control, which I could not find a single document online.
DP2.
It's just DP2. It was a 2-wire.
Number 2, not 2 eyes.
Yes, number 2. It was a 2-wire switch. like dummy switch,
Mhm.
no powered, just a 2-wire dummy switch. And finally, when I got a hold of Greg after he was done teaching in SARC from Bitzer, who's awesome, he ended up getting a hold of somebody for me. And the switch is normally open when there is oil pressure, and it closes when there's no oil pressure. So meaning if the magnet in the actual like transducer assembly, what they call it, which would be like the brass piece that's in the oil pump, when that magnet is close and pushed up to the actual like sensor piece, the black Crewon sensor piece, it closes the contacts. When it closes the contacts, it sends the signal to, like how Brett shows, it's got a spring in there. It sends a signal and closes to the CMRC to tell it
you have oil pressure.
you have oil pressure problems. So that was the only thing that was confusing, because of the way they had the wiring diagram. They had it where the switch should have been, they had it showed in the running state, not in the state it would be in normally.
See, that's what makes me angry. So, like, it's weird because sometimes you'll have schematics that do that, because typically all schematics are the way they're supposed to be shown is no power and no pressure applied.
Correct.
But I don't know how many times I've seen, like on prints, you'll see a low pressure switch normally closed, which really doesn't make any sense, because theoretically, if the rack runs out of gas, that switch would be normally open.
Correct.
And so same thing with this. So you said the schematic on the thing was drawn how again? It was drawn closed?
It was drawn open. So it would be with oil pressure.
Gotcha.
But like it didn't note it. And then the other thing that was a little confusing is the high pressure switch terminals on there are internally powered through the board, but only when it calls for it to run. So
almost like when you use a current sensing relay, like for an oil timing thing, but instead of the current, and instead of for the timing circuit for the oil, it's doing it for the high pressure.
correct. So when CN1 on the board, or CN1C, gets power, which should be from your safety circuit, it gets power, and there's a closure on the forward run. I call it the forward run, but the enable, it closes internally on the board. It closes the high pressure switch, and it wants to see voltage back on the other side of the high pressure switch. So it's like a safety line circuit like microthermo would have. So it's just a safety line where it's looking at it. It's not actually breaking, it's doing it internally, which was a little confusing, but once I got it explained to me, it was like simple. Just had to change some of the wiring up, but that the way they showed the switch was super confusing. But now that I understand it, and it makes sense now.
And that, I forget, what's that control called again?
It's a DP2.
No, not that. The actual, the unloading, the whole unloading shebang.
CRMC2 or CRMC, but it's this was an 01. Apparently there's an 02 for newer compressors.
CRMC 1-01.
But other than that, it just took right off. Everything came preset up. Like all the unloaders were wired already. All the oil control was wired.
Yeah, actually, when you called, or when you texted, when I finally saw the thing, because I was teaching, I think the same time that he was, and I walked up to him, and then I looked at the chat, and I was like, "Oh, you got your answer." He's like, that, and then before I could even get out of my mouth, when I looked at my phone, he's like, "If you're calling about Kevin, I already took care of it." And I was like, "Okay." I was like, "Hey, look over there, a bird." I literally grabbed the CRMC, because I've been trying to like take one from him every time I see him, and right now he's slow because his arm's still broken. Like last time I saw him, I had a better chance when I saw him out in Irwindale because his arm was in a sling. I would have had a better chance of running off because he probably couldn't have called me at that point, but this time he's out of the sling, so I didn't want to run the risk.
Greg's great. Like he's an awesome resource.
Yeah. So he actually said to me when I saw him this week, he's, "Man, I'm going to come on the podcast." And I was like, "Really? Seriously? For sure this time?" He's, "Yeah, see, it's different now because last time I was supposed to come on, my brain got scrambled from COVID and I couldn't think straight." But no, we were joking back and forth, and he wants to come on and talk about some stuff.
CRMC definitely. Like I've done some of the earlier CMRCs where they were still tweaking in here and there. Like they work great. I wish you could adjust the liquid injection a little bit though.
No, nothing in there for that, or maybe you didn't have the like.
I don't think I had a high enough password to give it just a little bit more. But other than that, it did phenomenal. It completely smoothed the rack out.
Okay, so my question is about that because typically they'll size the stuff for 35-degree suction. Even like the actual physical superheat, they'll size it for a 35-degree. Is it was it cycling off and on, or just wasn't feeding enough?
It wasn't feeding yet. I was in the mid higher twos, like 210, 215. It's right in the cusp. But it was doing what it was supposed to. It's got that on there for protection, so it's got that discharge chemister in there. But it literally took the rack from a 35-pound delta pressure for low temp down to like 8 or 9. And it definitely needs some more tuning, and I'm waiting on Copeland unloaders. So once I get those and I could shed some more load on there, I think that rack could be a million times better. So unfortunately, this rack has a 25, and then on the medium temp, it's got a 15 and a 15. So it has a 0 staging.
Oh, gotcha. So no matter what they do, it kind of eats shit all over the place.
Oh yeah, because the controller is just a potato. Try this one. It's just baked potato.
Run some liquid in it. Damage some valves.
You're just hosed because it has no staging. So we're adding unloaders to everything else. So once we get the rest of the heads for the Copelands, it'll have a lot more staging.
Gotcha. So it's not the IQ module? Is this what it is? Let me show this.
Yes. But
Okay.
they call it CMRCs, but so see a 6-cylinder can go from 10 to 100%.
So that's what you're talking about, where basically the lines go up through on top of there, basically bolts on there. That's what you were speaking of.
So that gray piece is the only thing that bolts, that piece with all the weird European plugs coming out of it onto the left. That's the only piece that gets added.
By the way, this presentation, if you want to grab this presentation, this is actually a presentation is from, I think, one of the NASRCs, I think over in Irwindale. I literally just downloaded it. So if you want it, every single presentation that's on there.
So it's not possible with the TCs, but I heard it's coming.
Yes.
Which would be cool, because could you imagine running a drive on the lead and having an unloader or two on TC compressors? That would solve all the issues with the staging we have.
I think it's talking about the field retrofits. Wait, Vari-Step is not possible on TC mode. Oh, maybe. Oh, okay. Oh, TE. Sorry. Okay.
Yeah.
But not the TC ones. Gotcha.
I heard it's coming. I was talking to some Hill people, and they were talking about it. I've seen the subcritical ones with it.
See, I never have. I've never seen one of these compressors with it on there.
I think it works great. We did the last Costco I started up, we had them on there. We had the integration with MT. That was a little rough in the beginning getting it going, because that was like the second store. There was still a lot of figuring out when we were doing it, because it goes to, I believe, a Modbus daughter card, and we're taking that and we're interfacing it. So I believe Copeland has a license for it. So I believe they can communicate with it. I'm not sure about Danfoss. I'm sure this is European, so I'm sure Danfoss has got to have something, because if it's here, it's probably been in Europe for a little while longer too.
Probably.
The microthermal integration, we were able to see everything that we could see off there, and you could also reset it remotely, which I believe on the E3 or E2 one, you should be able to too.
So you can see the discharge temperature, because there is also, I'm pretty sure on there, there should be like a discharge and suction pressure transducer on there. Is there not?
I didn't have them on mine because this was a retrofit, but yes, you could have the discharge and suction transducers on there. The one thing we did find with this, when the first time we went around with it, is there's envelope protection or envelope protection. You got to make sure it's set to where it doesn't kick you out too far on your suction, because if you hit below the suction, it would lock out. But
wait a minute, how the hell does it know that if it doesn't have the transducers on there?
Only if it has the transducers.
Oh, I see what you're saying. So if you were to have something go awry with the program where everything just freaking buries,
Yeah.
that thing is still going to have control. And so if it were to go outside its envelope where this one would have a suction of X, it would basically say, nope, not today, Johnny, and basically just shut down.
Yeah. And then it caused some random lockout issues. But like the head pressure one, I totally agree. It keeps it from blowing a relief again. It's one more layer of protection. But no, it's super simple. Everything came pre-wired. You can order them if you order the oil control. It all comes pre-wired. Like you order that oil control, it's all pre-wired.
What kind of oil control is that?
It's the Crewan.
Makes me sad.
Yeah, I like the cold oil controls.
I do.
But the crankcase heater and everything pre-wired.
I see that. It's being able to measure everything. So this has an actual discharge temperature thermistor then.
Correct.
I know usually on and I'll admit that I actually did this. So I did maybe a retrofit or two where I put that sensor on there where I thought it was a temperature sensor. It was not. I knew it was a switch, but what I did not know that you weren't supposed to put power to it. You're laughing because you did the same damn thing.
I did.
Your shit.
I did.
And you're like, why do I keep blowing fuses? This is really weird. Why is this happening? Because it's not rated for that. So if you do you have the sensor that basically just goes to the Crewan? It's just an open or close, and you're supposed to run it to where the sensors are. And if you run it through the control circuit, you'll start blowing fuses, and you'll be like, I don't know why I'm blowing fuses. Everything looks good. I'll admit when I mess up, man. But you don't find out right away. You find out within 2 or 3 weeks.
Today's episode is sponsored by the RefraShield RDP Series differential pressure monitors from Westermeyer Industries, now available for transcritical CO2 systems in addition to other common pressures and refrigerants. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace that filter? Wait too long to replace, and you could end up with a nasty filter blowout. But replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The RDP Series differential pressure monitors, including the new transcritical CO2 model, are available now from Westermeyer Industries. To find out more information, email sales@westermeyerin.com. That's WESTERMEYERIN.com.
Yeah. So like ordering this, like I went right through bits or parts, gave them the model number and serial number of the compressors, told them how many unloaders I wanted, and that was it.
Really?
So then setting it up it came blank. So I had to go through and program everything, which used the Bits or Best tool. And you could either do it on your phone or the computer. I recommend the computer for like if you're programming from scratch, it's a little bit easier. So going through there, like you got to program the model and serial the compressor, choose that, and then you got to tell it if it has Varistep unloading, and then you have to tell it that if it has liquid injection or not. So it'll enable the liquid injection because it has its own terminals on there for liquid injection where it supplies the whatever the control power is to it from there. And then it was pretty simple after that. It was just, okay, what is the minimum compressor capacity? If it's 2 coils, if you got 2 heads on a 6-cylinder, it's 33% is the minimum. So super simple.
How come you didn't order one for all the heads?
Because this was done like on a project to make it go away and like the cycling issues, and
You would have to replace another head.
I would have to replace the center head on them, and I'm already waiting like a month and a half, 2 months to get the Copeland heads. So because they're on back order for these random compressors, we just went with this. We were trying to get something as fast as possible to get this to stop like eating itself.
It was just cycling itself to death.
Oh yeah, dude, it was awful.
I'm trying to remember if there's an orientation where if it was regular standard unloading, which head is it the center head has to unload last, right?
I believe so. I've always seen it unload last.
I wonder if it's in presentation. Yeah, so you can see here you have the high pressure switch here. our high pressure transducer on here, you get the low pressure transducer on there, and that's where he was talking about if it's running outside its operating envelope. So I'm assuming you probably have to program what model number compressor and
Correct.
what bits are best app from the get, right?
Yep. Yeah. So like the first thing that's literally the first line item in there when you go to do it is what model compressor is this and what's the serial number, and it goes through that.
Yeah.
And then
here's that temperature sensor that I was talking about. That's not a temperature sensor. It's basically the ClickSon, and it's not supposed to be ClickSonning with high voltage through it. And then there's the other temperature actual sensor that goes to the CRFC.
the other nice thing is it reads the PTC sensor in the motor.
Ooh.
So you got that. And then the coils, you got to make sure of this because it was weird with the kit. They gave me 2 random coils with it too. But the coils, the blue coils down there are the correct CMRC coils. Like they're high cycle count, like pulse valve type coils.
So different part numbers then.
Different part numbers. But you got to pay attention to this when you're looking at this. And when I went through and sized these, it matters what envelope and operating envelope you're in, because some of them you may not be able to unload all 3 heads because it may need the cooling. So like some low temp situations, you may not be able to unload all 3 heads. You got to look at the that Bitzer software where we check the compressor efficiencies with. You got to look on that and make sure that you could set it up for Veristep in there. Make sure that you're going to be in an operating envelope.
I don't think I understand. Are you talking about because the suction return temperature coming back from it, or
that? And like when you're unloading all 3 heads, you have very little flow going through the compressor, so it's going to heat up real quick.
oh shit, yeah, because it's still suction blocking, right? It's still a
Correct.
suction blocking compressor. What we mean by that, just if you don't know, the easiest way for me to really understand, I'll show you a picture. But essentially, when this thing unloads, this is going to
Can you
push.
zoom in?
No, yes, again. Find a way. I have my drink there.
There you go.
Go ahead. You want to explain?
No, go ahead. You're better
All
at this than me.
I'm assuming that this would be the suction side. So if this would unload it, basically, let me just make sure. Suction chamber. Yeah, suction chamber number 2. So when you get pressure on there, wherever it's pulling the pressure from, probably the oil, there's probably something internal in there or from the discharge pressure. And it pushes down on this whenever it's energized and then essentially blocks off the suction. It's comparable to you ever go down the road and all of a sudden you hear a tractor trailer go like real
brake.
loud. Yeah, it's a Jake brake.
Yep.
So in a Jake brake, they're actually opening up the exhaust ports. We're not opening up the exhaust ports. We're essentially blocking the intake port, if you will.
Yes,
Go ahead. Correct me if I'm wrong.
in a
That's the way I'm
sense,
interpreting.
it depends. Like a turbo brake, like on a Cummins, it blocks the exhaust. It closes the turbo vanes off and chokes the turbo down. So it blocks the exhaust. So it's a little bit different on a Jake brake, but same concept but backwards. So you're blocking the intake here instead of the exhaust. So like it's like a screw compressor with a slide valve. That would be blocking.
That's what I said. You're blocking the exhaust aren't you opening up the exhaust in a Jake
No,
brake? And that's why it sounds so loud?
You're blocking the exhaust.
Blocking the exhaust. Okay, I'll take your word for it. Someone told me a long time ago, then they lied to me. Liars.
They float the valves in a semi. Like it's a little bit different, but like this is block suction unloading. So obviously when you block that suction, guys, you're cutting down your motor cooling. You're not moving as much gas through that compressor. So your volume is decreased. So your heat content of the cylinder walls and everything else is going to increase because you don't have that gas coming in that's cooler to help cool it down. So your discharge temps increase. It's the same thing on the IDCM compressor where like at a Copeland, the more they unload, the hotter they get. So that's why it's very important to have a good superheat when you're doing this. That's why if you look at that Bitzer software and it tells you like, hey, you're outside the envelope with all 3 heads under these conditions. So that's something you just need to be aware of. It may not be worth it to unload all 3 heads if you need to, but that's where it'd be nice if you could write and read from like the controller to that. Say, hey, under these conditions, we can unload all 3. Under these conditions, we can only unload 2. That'd be cool, but that's a lot of complication on there.
Yeah. Yeah, so like I said, low pressure, High pressure. That you said that one had liquid injection. Where are you putting the liquid injection on this bad boy?
So this one, the OEM had it going into the suction.
Oh.
So it was already pre-done.
Yeah.
Yeah, like I didn't mess with that. I just wired the coil into the liquid injection pulse.
Gotcha.
And then the other thing is you could set it for part winding start. Like it'll do the part winding start for you. It has the timers built in and everything. Or you could set it to start unloaded, which I don't know why you really want to start loaded. You're decreasing your current starting unloaded.
Agreed. It even has Y delta start.
Yep.
That's weird. These compressors aren't that big, but I guess in Europe where you don't have as much brand new energy lines, everything's rarely old, unless I'm totally just talking on my ass as far as like the infrastructure or whatever. But
I'm pretty sure this module is applied across like multiple compressor platforms for them.
Gotcha.
And then same thing, you can make it 0 to 10 volts, or you can make it 4 to 20 milliamps. I've been seeing a lot of stuff here lately coming out 4 to 20 milliamps, which I mean, a lot of the control world thinks 0 to 10 is like the peasant control.
They do, but you got to remember also a lot of the building controllers run across buildings. We're doing everything right there. You know what I mean?
Yeah.
They do it because it's more accurate. Because even though you hear 4 to 20 milliamps, they are using those first 3.5 milliamps or 4 to essentially power up the device, and that's really why. And then you get more of an accurate signal.
And you only need a 2-wire control versus 3-wire.
That extra wire costs so much.
Yeah, I mean, in their eyes, to the peasants, meaning us, yeah. I mean, it is a little bit more accurate, but obviously, it takes more skill to measure it. So, I would take a 0 to 10 any day. I could walk an apprentice through, put his meter on 0 to 10, and looking at that any day.
And if you guys don't remember, we literally just talked about this the other week, where if you have to check a 0 to 10 or 0 to 5 or 1 to 6, whatever the hell signal that you're using, you just measure like where the terminals are actually going into the unit. Where when you are using a 4 to 20 milliamp, you can either buy that really expensive 6 or 7 or whatever they're going to up $1 meter, which is an amp clamp on milliamp meter, or you can just pull the one lead off. But then, unfortunately, the pressure transducer is not going to read for a little bit. And if that happens, typically the rack's no fail-safe controller shut down, whatever it's going to do.
Yeah.
But it even actually shows you here, like there's your 0 to 10 signal. And then basically it's showing you, depending on what model number, like how much or what it's loaded to.
Yep.
All right. And, what's that? I didn't see that. Oh, additional port on CR head. Leak bus testing factor. Oh, for the pressure transducer. Right?
Yeah.
Did yours have that on there or no?
No.
That looks like a TC head, doesn't it?
It looks like a TC head to me.
Yeah, no, because how many bolts, right?
That 100% looks like a TC head.
Huh.
Because even my valves weren't like that, and like I didn't have those 3 bolts in the middle.
Yeah, that definitely.
That looks like a TC head.
That's weird because that's the unloader stem right there. Remember how you said? I think the retrofit you can't do.
Look, see, application monitoring kit transducer rated for higher pressure, and look at the bar. Is that in bar on the side?
Yes. Oh shit. Yeah.
120 bar. So yeah, that's got to be a TC head.
100%. 100%. And then this is probably the Bits or Best app where you can connect to it, or like you said, you can connect to it via. You have to have that whole setup with the software. This is basically the same one, I believe, that gets hooked up to the newer VFDs. The newer very cold VFD.
I lost the damn adapter for that thing. And I was so fucking pissed.
What did you do?
I lost.
You had to use the Bluetooth then.
No, I lost the adapter for the Verispeeds where it's the RJ45 to 11.
Yeah, this one right here.
No, I have that
this
piece
right here.
because that one's got the RJ45 to RJ11 adapter that goes into there. That cord, I lost that one. Like right there.
Here.
Yeah. Because I have the other one because that's for the screws. The screws and the CMRCs are those green plugs.
That sucks.
Yeah. I might have to make one, but yeah, right here you have your faults and your lifespan counters. So to reset the faults, I was just power cycling it. I had it wired all jacked up when I was doing it because the way I had the high pressure switch wired and how I thought it had to get wired, it kept throwing a fault. So for high pressure switch being open, it turned out that the skids were wired, low pressure switches were switched from compressor to compressor. But
That's good. That's really good. That's all right. I was working on a rack the other week. I think I told you. Most Husband racks, they have the backup relay, right? So the low pressure switch basically is never in play unless the system goes, the EMS fails, right? Then it'll do that backup relay. But
switchback.
The switchback relay. But it was never installed. They never did the program for the switchback. So we're doing a non-condensable test. So I was like, yeah, you just give it a little bit. The compressor shut down. The compressor shut down. The compressor shut down. And I'm looking at the pressure transducer. I'm like, why does that say negative? There's no and so I shut off all the switches real quick.
So I just did a Danfoss on Thursday or Wednesday. We did some 800A conversions from 255s, and we just copy the programs and I convert them on an 800 and then switch them to 800As. And it copies the program. Danfoss does a fairly good job of the copies. There's hardly issues. So I go to throw them in, and the two apprentices were like, hey, we're testing stuff. And the defrost works, but the compressors aren't shutting off. I'm like, compressors aren't shutting off. What do you mean? So then I went to my rack and I went to go override a compressor off. I'm like, compressor ain't shutting off. The light in Danfoss turns off, flip the switch, nothing happens. I'm like, what the fuck? I pull the relay or pull the block out of Danfoss, nothing happens. I'm like, okay.
It was bypassing it through switchback. Yeah.
And so I'm like, that's weird. So I started looking, it's some janky block calculation in there. I'm like, this calculation's wrong. It's backwards. They have it where it's true for the last line. So it threw it as true because the way they had it, the lines of logic, and then they had true at the end. The lines of logic were or, and neither one of them were on for the low calc for low suction pressure or high suction pressure, and then they had true at the end. It just threw true and turned it on. So I'm like, this is weird. This is wrong. So I pull up the 255s, and sure as shit, it's the same way. I'm like, oh, this has been running in switchback for forever.
That's not good.
So all three racks were like that.
That's no good. I gotta remember, but I did the switchback based off of if it's basically saw the communication from the controller. So if it saw the communication from the controller, if it saw the time, right? If it doesn't see the time, then it'll basically go back and switch back. And I proved it by first I pulled the power to the board, and obviously that was going to work because of how I had it wired on the relay. But then the other way was that I pulled the comms, and it took a little bit, but it finally went back into switchback.
See, I don't like switchback. I'd rather not be there. I think switchback was there when we had unreliable controllers, like when they were having RMCCs when the batteries died, or Comtrol when the batteries died and they lost the program. Let's be honest, the E2 was one of the most reliable controllers ever. Same with the E3s, already up there. The 255 was a great controller. I think we're past the need for backup.
I think it was probably, it's weird. It's a catch-22 because you really want it in there because if it were to fail safe, then that way it basically does everything. But it also depends on their manufacturer, right? Some manufacturers, you'll have one relay that goes to all the timers, right? And so basically it'll kill out all the Crozettes if that one low pressure switch is. I think because I've seen guys fight proof failures and they're like, I don't know why this thing's going to proof failure. And then the whole time it happens to be the low pressure switch.
Same with the Zero Zone. Zero Zone wires their low pressure switches in per compressor on some stores. Yeah. So it just depends on the manufacturer. For most MT sites, we don't have switchback. It just depends. The Danfoss, it gets hairy doing a switchback. It's some people do a low calc or high calc. I personally would, like, for the transducers to fail, they always fail in the negative. So I personally would have a low calc. Like, if it fails low, then that's the only time you're gonna need switchback.
But if it feels low, if it feels like where it go, like literally goes into a vacuum, then it's going to open up anyway. It's going to shut down the rack.
Correct.
So that's why I just do just the time thing. If it can
That is a good idea.
if it can see the schedule, as long as you can see the schedule, then fine. You know what I mean? Because if God forbid, even if you lose the train, the module train.
But here's my thing to that. So we've had issues where, like, we lose a transducer. Okay. And when a Danfoss transducer goes open, it reads negative.
So it'll open up.
So it shuts the compressor. So it shuts the compressors down.
Better than running a vacuum. But I see what you're saying, where like you could potentially just have the pressure switch in there. But here's the thing: when people go in there, if they're going to do a controls conversion, they're going to do it exactly the way it is, right? They're not going to be like, I'm going to spend the extra 4 hours it might take to rewire in the low pressure switch.
Oh no, I'm not wiring them back in.
No, but what, if someone would decide to do that, like instead of doing the whole switchback thing, get rid of the whole freaking thing, and then just wire that low pressure switch, just reroute it where it would have been.
So if this particular customer, unless it's a Hussmann rack where it actually has a switchback and a bypass, all of these racks, the switchback only bypasses the EMS relay.
Yeah, that's all. Wait, what?
It only bypasses the Danfoss or CPC or Comtrol compressor relay. That's it.
No, this was switching between.
Yeah, it has the relay on there where it switches on the Hussmann racks, like how they're set up, and it puts the low pressure switch in play or not in play.
Yeah, basically. Yeah. But on this one, the one I was working on, got rid of the DO for the Danfoss and basically was straight relying on the low pressure switch to make and break.
Yeah, see, these, all it does is get rid of the DO. The low pressure switch is still wired in series on the safety circuit, but it just gets rid of the DO.
Oh, God. Yeah, I'm sleepy. To think that I would spend more time sleeping at the airport, but I'm always like afraid that I'm going to fall asleep.
I would afraid you get robbed. Like, just somebody run off with your bag and just.
My head is always on my bag. And I always actually clip it to my belt.
Yeah. My bag's really heavy.
So is my head.
So is your head.
All right. I think that's enough. We can talk about that.
Yep. All right, guys. Have a nice one.
See you guys next time. Bye.